Okay, last chapter, chapter 14, replication transparency and real-world importance. So there are a few different types of replication. We'll discuss that first. One is just direct replication. This is just where a study is basically repeated exactly the same, as closely matched as possible to the original. And sometimes this is done, you'll see two replications of a study published in the same paper, which helps provide a little bit more oomph to the results. More likely to get published if you can show, hey, this wasn't just a statistical fluke, it wasn't just some extreme difference between means that we happened to find by chance alone. This was a real effect that we could replicate. One thing that needs to be kept in mind, though, is that if there are any threats to internal validity that existed in the first round, they're going to exist in the second round, and it doesn't necessarily, it still shows just that narrow effect that the initial experiment showed. So expanding on that a little bit is conceptual replication. This is where you have the same conceptual variable. In this case, in this example here, you have thinking about alcohol, and does that lead to aggressive thoughts? And then the replication is it's a different study, but it's investigating basically the same question, just doing it in a different way. Instead of showing pictures of alcohol versus plant photos, it's actual advertisements, and then instead of a reaction time measure, it's ratings of ambiguous behavior in a story about Donald. Okay, so if you find a similar effect in both of these, then that's stronger evidence that there is this relationship between thinking about alcohol and aggressive thoughts, because you're observing that same effect across multiple settings, and even when you're asking the question in multiple ways. Replication plus extension, this is kind of a mix of those first two. This is where you have a direct replication, but then you also add some additional variables. We talked about the study earlier with note-taking versus laptop and ability to retain information. And here's a replication. You can see that the effect didn't really hold up, so there could be some issues with the study. Now, just because one replication has failed to find the same effect as the original study doesn't mean that the original study was bogus. There could be some important differences between how the studies were conducted in terms of sample, setting, or just maybe some changes in experimental design that weren't really caught or that weren't really thought about but actually are critical. So this is not necessarily the be-all end-all, but it is important to note that if a finding can't be replicated, then it probably wasn't very real. Okay, so here's an example of where a bunch of labs have tried to replicate the same study. You've probably heard about this in Psych 1010, where if you hold a pencil in your teeth, you kind of force a smile, versus if you hold it in your mouth, you force a pout. And if you hold it in your teeth, then you're more likely to rate, or you rate comics that you read in a newspaper as being funnier. Okay. So here's the original study here. Here's their effect size with the confidence interval, 95% confidence interval. And these are all the replication studies. Some found an effect in the opposite direction. Right, and all in all, they all contain 0, and so it doesn't really seem like there's much of an effect. Now, the textbook discusses how the original author acknowledges this, but that there are some key differences between these replications and his original study. Anyway, that's up for us to decide, I guess. Here's an example of multiple studies that all kind of fall under the same concept of priming, different ways in which that you can observe a priming effect. The original study was, anyway, the details of the studies aren't important, but basically exposure to some number, for example, if you're trying to estimate about it. So the original study, they had people estimate how many babies were born every day in the U.S., and they either told them fewer than 50,000 are born in the U.S. every day. How many do you think there actually are? Or they said more than 100 are born in the U.S. every day. How many do you think there actually are? And depending on whether they got the high number first versus the low number, they changed their estimate. They tended to think higher if they got that first anchor point of 50,000, and they tended to think lower if they got that first anchor point of 100. Okay, so that's this study here where they found this effect, and that's the study here, and then other studies have found similar effect sizes. This has been replicated. Now this is different questions, so more conceptual replications, but showing overall a pretty consistent effect that it does happen. Sometimes you can't really, or sometimes it's difficult to replicate a study, and some reasons for that might be that there's something about geographical differences or sample characteristics that just made it so you found the effect there, but you don't find it doesn't really generalize. Sometimes there could be issues with the original studies, which we'll talk about in the second section. Things like how the statistics were conducted, not necessarily in a malicious way, with intent to deceive, but just it could be just lack of knowledge of best practices, or things that weren't fully known on how to handle certain statistical problems. Rarely you do have issues where a finding just can't be replicated because of fraud. So here's a relatively famous example. This was an article in Science, a very prestigious journal, showing that opinions can change drastically due to canvassing. And this was later retracted because it was found that Michael LaCour, the main author, fabricated this data. And somebody else in this field, which kind of illustrates how science is, the honor system is self-enforcing in the scientific community. Somebody tried to replicate this and wasn't able to do it, or found some issues with the design that just didn't make sense, and eventually it was found that there were issues with the stats. So this one was retracted. This is a pretty rare case, though, that something like this happens. A meta-analysis is kind of like a replication. It's as the name suggests, it's an analysis of analyses. Okay, so this is put together in one paper. So you're not. This is not a replication in the sense that it's just a duplicate of the first, but this is where you're looking at many studies that were all conducted about a certain question, and then you kind of pool statistically. You can pool the results together to find things like the average effect size, okay, across all these participants. Okay? And this is just illustrating results from a meta-analysis on reaction time difference between when participants are telling a lie versus when they're being truthful, showing that it takes longer. Reaction time is longer when you're lying. So meta-analyses, you'll see those in the literature quite a bit. They can be quite useful to see what the overall state of the field is, and see what the across multiple studies how strong an effect is observed. Here's an issue with meta-analyses, though. It's called the file drawer problem. Just that what actually makes it into publication, what actually gets published in journals, tends to be positive results rather than null results. If you found no effect of something, it may just sit in your file drawer, and you don't actually even try to publish it, because at least historically it's the case that the journals are less, they find null results less juicy, right, less exciting. There's some efforts to try to help with this, which we'll talk about in the next section. but it can be an issue. A meta-analysis, therefore, will show a greater effect than actually exists because it's leaving out a bunch of studies that showed no effect, or maybe an effect in the opposite direction. Okay. Antidepressants and depressive symptoms, for example, if you were to look at just the published results on antidepressants, you'll see that 94% show that antidepressants are effective. However, clinical trials using these drugs actually need to be registered with the NIH, and some of them don't get published, some of those registered studies. So when data was examined from all the unpublished and published studies, then it showed only 51% of the studies showed an effect of antidepressants. It's important to keep in mind you don't always find an appreciation in the popular media for replicability, and journalists usually don't latch onto a replication study and see that as a really exciting thing to write about. But responsible journalists, and this seems to be more the trend, those who are science writers in journalism seem to be, or they should, and it seems to be getting better. They should summarize the body of literature on the topic. Okay, give some context to a finding, where it's not just summarizing the results of this one paper, but saying here's what's been shown in the past, and this is consistent with that, or it's not consistent with it. And of course, when you're writing your literature reviews, this is a big part of what you should do too. You shouldn't treat one study as the be-all, end-all, but make sure you put it in the context of other studies that examine something similar. Okay, and we'll move on to part 2.